So this was pop quiz 1 related to simple magnetism. In the first question, 10.3 shows a view from above, like we are looking at a card, and from above, a vertical wire is there which is carrying the current up. A wire is carrying a current up. A centimeter grid is marked on the card. Point W is 1 centimeter above the point W is 1 centimeter vertically above the top of surface of the card. So, for example, if a wire is carrying current, it will produce a magnetic field, and the magnetic field will be circular around the wire. It will be circular. So closer to the wire, the magnetic field will be stronger, and away from the wire, the magnetic field will be weaker. So when we compare, state the magnetic field strength is at S, at T, and at W compared to R. So if we compare with R, because S is closer, so it means at S it will be stronger. But T and W are same distance, like if this is 1 centimeter, this is 1 centimeter, and this is also 1 centimeter. So T and W are the same distance from the wire. So the strength of the magnetic field will be same. That's why the first one we write stronger as it is closer. And for the second T and W, we write it is same because it is same distance from the wire. Is it clear? Yeah, the height does not make difference because the idea is that if we have a wire, like if this was a wire, and I say if one point is 1 centimeter above the wire and the other point is 1 centimeter below the wire, it does not make difference. If the points are same distance from the wire, they will have the same strength of a magnetic field. So strength of a magnetic field depends on the distance from the wire, not the position. It can be above, it can be below, it can be towards right, or it can be toward left. That does not make difference. The distance is the one which make a difference. In question 2, a permanent magnet is made from only one material. So the permanent magnets are made up of steel. So underline the material from which permanent magnet. If it was a temporary magnet, then we'll mention soft iron. An electron source produce a narrow beam of electron that travel with the same speed. That all travel at the same speed. Electron source is placed in a vacuum, and north and south poles are there. Describe what is meant by the direction of a magnetic field, and it said the direction of a magnetic field between the two poles. So what is the direction of the magnetic field? So direction of a magnetic field is actually a direction of the force on north pole. And in this case, what is the direction of the magnetic field? It is from north to south, or we can say the direction of the magnetic field is towards right hand side. So if the question is what define, like what is meant by the direction of magnetic field? So direction of magnetic field is a direction of force on north pole. Like which direction the north pole experience a force, that is refers to a direction of a magnetic field. Because if I place a north pole here, it will move away. If I place a north pole, it will move towards. So the direction of the magnetic field is actually a direction in which the north pole experience the force. And the second here point you have to write here that it is towards the right hand side, that because state the direction of magnetic field in figure 7.1, that's towards the right hand side, or you can say it is from north to south. Is it clear, this one? In the next question, put a ring around the name of a metal which are attracted. So we need here a magnetic material. So aluminium is not a magnetic material. Copper is not. Iron is there, not mercury, not magnesium. Steel is a magnetic material, not tin. Nickel and cobalt also magnetic materials. Here we want to mention a magnetic material, so that's why we underline both of them. Figure 11.1, a magnetic field pattern is there on a diagram. Label a north pole. So magnetic field is out from north and into south. Near the poles, the magnetic field is stronger as compared to away. Far from, as we move away from the pole, the magnetic field get weaker. Here we have to write north and south poles. So here we have to write north and south pole. So this will be a north pole. This will be a south pole. And if this is a south, so this should be north. And if this is a north, the other one will be south. So distribution of the mark, if you did this correctly, you will score 1 mark. If you do all the poles correctly, you will score the other mark. But some students forget to they write north and south and then stop. You will lose the mark here. Why you will lose a mark? Because you have to label all the north and south pole which should appear. If you write like this, you will lose a mark. That's why you have to put all the poles here. Then which diagram shows a pattern of a magnetic field for a solenoid? So when we have a coil or a circular wire or a solenoid is there, between the wire, the magnetic field pattern, the lines are straight, and around the wire, it's like a bar magnet. Like that's a pattern of a magnetic field for a solenoid. So this is not correct. This circular not correct. This also wrong. So D, between there are straight lines, around it will be circular. So D will be the right answer. In question 5, a permanent magnet is placed close to a bar of a soft iron. So what happened? So because iron is a magnetic material, magnetic, even if it was a steel also magnetic material, and magnetic materials are always induced magnetism happen. So if you bring a north pole, so this will be south and this will be north, and as a result it will move towards the magnet. So P will become the south pole and it will be attracted towards the magnet. In question 6, you have to sketch the direction of a magnetic field. The direction of a magnetic field is out from north and into south. So if we check A, so the magnetic field pattern appear to be correct for A. Why not B? Why B is wrong? Because this one is right, but when we check the other one, like the direction is opposite. So that's why it is wrong. For C, it should be in this manner. The compass should point in the direction of a magnetic field. So it's wrong. And D, again, it's given towards the north and towards the south. So that's why D is also wrong. So A is representing the correct direction for the magnetic field. The next is a student carries out 4 tests with a magnet, which result show is not correct. If you bring a magnet and an iron bar, so iron bar will be attracted. So this result is correct. If you bring opposite poles, 2 magnets are there, unlike poles attract each other. So that's also correct. If we have a non-magnetic material, copper is a non-magnetic material, so there will be no effect. If you bring 2 magnets, again, opposite poles are facing. So unlike poles attract each other, so it will attract, not repel. So option D, the results are not shown. correctly. In question 8, the diagram shows a straight wire which is carrying a current into. So whenever a wire is carrying current, you have to use a right hand rule, the right hand grip rule. According to right hand grip rule, your for a straight wire, your thumb represents the direction of the current. So in this case, a wire is carrying current into, so your thumb should point towards the screen. And your fingers will turn, like grip the wire using your right hand. Your fingers will turn around it. So in this case, your fingers will turn around in this manner. So which one is representing a correct pattern? So B is representing a correct pattern. That is when the current is into and your thumb is pointing towards the screen and fingers will turn around. Is it clear? In question 9, two bars are held together. At least one of the bar is a magnet. The bar repels each other. So because if it was a magnetic material, for example, if we have a magnet and we bring a magnetic material, so magnetic materials are always attracted. So it will never repel. Like if I bring a magnetic material near any pole, north or south, so it will always happen an induced magnetism and magnetic materials are always attracted towards the magnetic. But if we have two magnets are there, so when their like poles are facing each other, like north and north, so they will repel, or south and south, they will repel. And north and south, like opposite poles are there, then they will attract. Like if you have north south and we have south north, so in that case, they will move towards each other. So two metal bars are there, and one of them is magnet, and the bar repel each other. So if they are repelling each other, it means both of them are magnets. Because if there is a magnet, they will attract, and one side they will attract, and the other side they will repel. So if we have a permanent, like two magnets are together, one side they will attract, one side they will repel. If we have magnetic material, like example, iron is there or a steel is placed near the permanent magnet, then they will always attract. So it shows that they are both magnets and there must be a like poles because identical poles are there. When like poles are facing each other, like poles will repel. So C will be the right answer. Is it clear? How we identify that both are magnets? Because if they were not magnetic materials, then they should always attract and irrespective of any pole. But because they are magnets, so for magnets, one side they will attract when their opposite poles are facing each other, and the other side they will repel when the like poles are facing each other. Which row in the table shows the magnetic poles? So iron will be attracted by induced magnetism. So what pole will be here south and what pole will be here north? And this piece of iron will move towards the magnet. So it will be south and north in attraction. So C will be the right answer. Four plotting compasses are placed. Which compass is shown pointing in a wrong direction? So when we draw the magnetic field lines from north to south, so it appears B is correct direction. And magnetic field is into south, so A is also correct direction. When we check C, pointing from north to south, so C is correct. But about D, because the magnetic field line should point into, but D is pointing out. So D is the one which is pointing in the wrong direction. So for this one, D is the correct answer. two bars of a soft iron placed near the bar magnet, and always induced magnetism happen for iron. So if you bring a north pole, so this will be south, this will be north, and this will be south, this will be north. So at P, it will be a north pole, and at Q, it will be a south pole, and opposite poles will attract each other. So and P and Q will have unlike or opposite poles, and unlike poles of a magnet will attract. So B should be the right answer for this. Question 13. Some electrical devices require a magnet which may be switched on and off many times. So we want to use it, like we want to reduce or switch off the magnetic field. If it was an iron, then only it can happen. If we use a steel, steel will be a become a permanent magnet. If steel is magnetized, then it will form a permanent magnet. It won't be an electromagnet. So because what is an electromagnet? Like example, a piece of iron, and we are passing a current around it through the wire. So when we pass the current through the wire, the current will produce a magnetic field which magnetizes this material, and this material will behave like a magnet. That is called an electromagnet. If we use an iron, when there is a current in the wire, it will behave like a magnet. When there is no current, it will demagnetize or it will lose its magnetic properties. But if you use a steel, then what will happen? It will be a permanent magnet. It cannot be demagnetized. So which type of a magnet may be used here? Only an electromagnet. Why not a permanent magnet? Because electromagnets are made up of iron and permanent magnets are made up of steel. We need electromagnet or iron here rather than steel. Otherwise, steel will make a permanent magnet and it won't be useful. In question 15, a hard magnetic material can be used to make permanent magnet and a soft magnetic material for a temporary or electromagnet. Which row shows whether iron or steel are hard or a soft magnetic material? So iron is a soft magnetic material and steel is a hard magnetic material. Iron will form, using iron, we can make a temporary magnet, or we can switch off the magnetic field if we want to, whereas steel, once it is magnetized, it will be difficult to demagnetize. In question 15, the diagram shows a magnetic field pattern around a current carrying conductor. So the idea is that the magnetic field will be around or circular. If we have a wire which is carrying a current, so the magnetic field lines near the wire, it's a stronger magnetic field, so field lines should be closer. Away from the wire, the field lines, the spacing start to increase, meaning the strength of a magnetic field is decreasing. So near the wire, the line should be closer, and away from the wire, the spacing between the lines should increase. That's why B will be the right answer. Why not A? Because in A, it shows that the first two field lines, in A, the first two field lines have a large spacing and then the spacing is decreasing. But what actually should, because the spacing between the lines shows the strength of a magnetic field. So near the wire, the magnetic field is stronger. That's why near the wire, the line should be closer, and away from the wire, the spacing of the line should increase. Means the strength is decreasing. So A is showing an opposite pattern. That's why B is the right answer. So this was a simple magnetism pop quiz. One which was totally related to magnetism and the properties.